colleagues and friends in our ongoing sharing in our YouTube channel, Wheeljack1 TV. So our topic tonight is developing electrical risers for tall buildings. So let us have our invocation. In the name of the Father, the Son, of the Holy Spirit. Amen. Amang banal, pinupuri ka namin at pinasasalamatan sa mga biyaya at sa tuloy-tuloy mong paggabay sa amin. Maraming salamat po sa pagkakataon na makapaglingkod sa aming mga kapatid at sa aming bayan. Sana po ang mga gawain ito ay magbibigay ng dagdag na kalaman, kakayahan at kaunlaran ng bawat isa at para sa aming bayan. At sana po ay ilayo mo po kami sa sakit, lalo na itong COVID at sa mga sakuna. Lahat pong ito ay aming tinataas sa iyo, dakilang Ama, sa pangalan ng iyong anak na si Jesus. Amen. So, I'm Engineer William Masintuan, a professional electrical engineer with over 45 years of practice as an electrical engineer. So we finished our electrical engineering way back 1976 at the National University, and we have been a professional electrical engineer since October of 1980.
Developing riser diagrams. Before a riser diagram can be formed, first, we must calculate the various electrical loads of the building. The fire protection system should be designed to size up the fire pump, the jockey pump, the air pressurization fans, and the toxic gas or carbon monoxide extraction pumps. The mechanical system should be designed to size up the air conditioning loads or chillers, the circulating water pumps and cooling towers, the ventilating fans in the restrooms, elevator motors, escalator motors, etc. The plumbing system should be designed to size up the various water pumps, booster pumps, pressure pumps, sump pumps, etc. The sewage treatment system should be designed to size up the various water pumps, aerators, filters, etc. It is highly recommended to seek the services of a reliable sewage treatment plant, STP contractor. Then the electrical and auxiliary, or ELV systems should be designed to determine the lighting loads, small power loads, water heating loads, the auxiliary or ELV loads, including FDAS, BAS, PABX or intercom system, Wi-Fi system, CCTV system, public address system, UPS or emergency power loads, etc. 1.0 FirePro Design Requirements. 1. Automatic fire sprinkler system. 2. Air pressurization system. 3. Toxic or hazardous gas detection and extraction. 4. Fire detection and alarm system.
Okay, according to the NFPA, you have to provide sprinklers if your building is, let's say, a hotel, a motel, a dormitory, or a hospital. Or if your building will, you will store flammable materials, then automatically you have to provide for sprinkler system. And if you provide for a sprinkler system, there must be a fire pump and a jockey pump. So these are loads. Otherwise, if it is not governed by these requirements, hotel, motel, dormitory, hospital, or there are no flammable materials, then usually what you provide there are equipment that do not need electricity. No, I mean no need to power up, no motor, no fire pump, no jockey pump. Which is the fire hose cabinet is in there, no, the Siamese twin or the fire department connection, which is simply provided for connection to the Bureau of Fire's hoses. Okay. So this is the provision in the fire code which mentions the requirement of putting sprinklers. No, it mentioned extinguishing requirements. Number 5. Letter A. All buildings shall be protected throughout by an approved supervised sprinkler system. So take note. There is some exception, but the exceptions are only very few. In the old fire code, only buildings with 15 meters high and above, meaning to say more than 5 stories, are required to be provided with sprinklers. But with the new fire code of 2008, even if your building is only 1 story, 2 story, 3 story, 4 story, or 5 story, or even meaning to say less than 15 meters, if the building is a hotel, motel, dormitory, hospital, automatically you have to provide the sprinkler system. Okay, so here are a schematic of the isometric diagram or drawing of a complete fire protection system.
1.1.7 Fire pump and jockey pump. Jockey pump pumps water from the fire water tank and maintains the operating pressure in the system 24/7 at 120 psi minimum. The maximum capacity is 10% of the fire pump's rating. Fire pump delivers fire water at the instant the reduction in pressure is reached due to the operation of the sprinkler nozzle immediately after the fire occurs.
So if your fire pump is say 30 horsepower, your jockey pump can be 3 horsepower. Okay, so here is a picture of fire pump, this one, and this is your jockey pump. So they are connected in parallel or piped together in parallel, except that it is the jockey pump that is always running almost all the time, pressurizing the sprinkler system, the hydraulic system. And the fire pump will only run when there is a fire. The moment there is a fire and there is a drop in pressure in the sprinkler system, in the header, automatically this will be sensed by the pressure controller or sensor, and it will automatically run the fire pump. So what runs the fire pump is the drop in pressure in the main header. Okay, so that's our fire pump and the jockey pump. Okay, but I'm going to share to you a rule of thumb as electrical designers in order for you to be able to gain time in designing. Okay, here is what I'm using initially before the designer of the fire pump and the jockey pump has not yet given me the load. So I use this figure 3 horsepower per floor level. So example, if you have an 11-story building, 11-story building times 3 horsepower per floor, you will be able to get 33 horsepower. So the next standard size is 40 horsepower. So let's have another example. If you have a 20-story building, 20 story times 3 horsepower, you will get 60 horsepower. So you can use a 60 horsepower building. So something like that. That's why that is how we do some rough estimating in order to come up with a load for the fire pump. And after determining your fire pump, you can now specify your jockey pump. Okay, you get 60 horsepower, so you can use a 60 horsepower building. So something like that. That's why that is how we do some rough estimating in order to come up with a load for the fire pump. And after determining your fire pump, you can now specify your jockey pump. Okay, so here is another way of looking at it, doing some shortcut. So let's say this is your area at the farthest point in the building. So let's just say you have this is a layout of a sprinkler system. This is a sprinkler here, there's a sprinkler here, here, and here, and also in here, 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 here. So you will notice that this first line here, there are how many? 9 sprinklers, no? 1, 2, 3, 4, 5, 6, 7, 8, 9. But take note, this blue line area, rectangle, is designated to be the sample area of analysis, no? So this farthest room from the fire pump on the topmost floor with 5 sprinklers. So this is it, no? The analysis and the hydraulic calculation is based on these farthest sprinklers. Itong pinakamalayo mula sa fire pump. Okay? So, here is an example of the hydraulic calculation provided for by the NFPA. NFPA 13, no? So, you would notice that by calculating the pressure of here, from here 7 psi, and then here higher than 7 until you reach this point, okay, then of course there is a pressure drop here in this 1-inch pipe, there is pressure drop here, and here. So we'll be able to determine the volume of water when these 5 sprinklers will happen to operate at actual condition, no? Kung may apoy dito, mainitan tong sprinkler nito, bubuga yung tubig dito. Kung lumaganap yung apoy at umabot dito, gagana rin to. Okay, so because fire protection is analyzing or what may happen in the worst case scenario. So you can assume that the fire could happen in this inside this blue rectangle area, no? That means what is involved are 5 sprinklers, no? 1, 2, 3, 4, 5. So the 5 sprinklers, therefore, after analysis, no, 1, 2, 3, 4, 5 sprinklers, then you will be able to determine that the pressure is about 19.6 psi, and the volume of water is Q. This one, Q 127.6 gallons per minute. Okay, at a pressure of 19.6 and a volume of water of 127.6 gallons per minute. This means that in sprinkler 1, there will be 21.2 gallons na lumalabas. And in sprinkler 2 naman, 23.3 gallons. No? And sprinkler 3, 25.3 gallons. Then sprinkler 4, 27.2 gallons. Then sprinkler 5, 30.6 gallons. So if you add all this output or volume of water coming out from the 5 sprinklers, you will get 127.6 GPM, gallons per minute. And again, the pressure is 19.6. Ganyan yan sa hydraulic calculation. Okay, so I'm showing you here a portion of the analysis, hydraulic analysis. By the way, we'll be conducting this next, I think next Saturday, no? Hydraulic calculations will be on July 11, if I'm not mistaken. Anyway, we post it in the Marvelous Solar page. Oh, Marvelous Solar page. So, just to give you an idea, Q sub S, the volume of water coming out in the farthest sprinkler is equal to 130 square foot area, and then times 0.15 gallons per minute per square foot area is 19.5 gallons per minute. And the formula for this is Q is equal to K times P raised to 1 half, or square root of P. A constant K times the square root of P, the pressure. No? Yan. Q is sprinkler flow, K is the sprinkler constant value as per NFPA 13, and P is the pressure from individual sprinkler in PSI. So, determining the pressure will be Q over P square, or 19.5 over 8 raised to 2 is 5.94 PSI. So, adjusting is because the NFPA says the farthest sprinkler must operate at 7 PSI. So, rewriting them, Q, the flow is equal to 8, the constant value, times 7, the pressure, raised to 1 half, or square root of 7, gives you 21.2. So, 21.2 GPM therefore is this value. Ito, 21.2. Okay? So, going back to here, the farthest sprinkler flow is 21.2 gallons. Roughly, the total flow for the 5 sprinkler can be made in a shortcut, no? 21.2 per sprinkler times 5 sprinklers give you 106 sprinklers. And then, because you need also to provide for a fire hose on the same floor of the sprinkler. So, assuming therefore that the fire hose is let's say 200 GPM, okay, then or 300 GPM, because you have to provide at least two, add the provision for a fire hose at the floor plus two adjoining floors, so 300 GPM. So the total required flow will be 106 GPM plus 333. Okay, so equals 400. Sorry, this should be 300. Ano? Mali ito, no? This should be 300. This 333 should be 300. May mali ito. Typographical error. 106 plus 300 equals 406 GPM. No? Sorry for that. Ha? So use 500 GPM pump. Okay, yun. So using a 500 GPM pump, ito yung formula naman ng horsepower. Horsepower is equal to 500 GPM. Ito, no? Horsepower pump motor. TDH here is the total dynamic head. 3960 is a constant value. EP is the efficiency of the pump, and EM is the efficiency of the motor, no? And Q is the flow, no? Which is the 500 GPM, gallons per minute. Okay, so applying it, 500 GPM times 71.56 total dynamic head. By the way, this is how the total dynamic head was estimated. No, 19.6 plus 12 floors times 10 feet per floor divided by 0.433 is equal to 19.6 plus 51.96 equals 71.56. So ilagay mo rito 71.56 times 2.31 given here in the formula. So now divided by 3960 divided by 0.7, the efficiency of the pump, and 0.9, the efficiency of the motor, 33.13. So you can round it off to 40 horsepower fire pump. So now to specify the fire pump is 40 horsepower, 500 GPM, 72 PSI total dynamic head, either 220 volts or 380 volts or 460 volts, depende sa voltage sa distribution design, no? 3 phase 60 Hz. Okay, take note, average horsepower per floor is equal to 33.13 divided by 12 is equal to 2.76. So use 3 horsepower per floor. Okay, so fire pump sizing on its floor, 22 floors, 22 story, 22 floors times 3 equals 66. So use the next standard size is 75. Walang 70 eh. So 75. Okay. Another example, sizing the fire pump for a 22-story building plus 1 basement. Remember, this is just example. So 500 GPM, the farthest sprinkler, and then here the total dynamic head is 119 times 2.31. Constant value is divided by 3960 divided by 0.7 divided by 0.9 gives you 55.18 horsepower, or next standard size is 60 horsepower. So specify your pump. Fire pump is 60 horsepower, 500 GPM, 120 PSI, 220 volts or 380 or 460 volts, 3 phase, 60 Hz. Okay? So, another example, this time for a 37-story tower building, 37 floors times 3 horsepower per floor equals 111 horsepower. So, the next standard size is 125 horsepower fire pump. Okay? So, if you happen to specify the jockey pump for this, you can simply use 10%, more or less, or you can use 10 horsepower capacity for your jockey pump. Okay, another example here, using for the 37 floors, Q. So the total dynamic head is very high, 184.14. Apply it here, 500 times 184 and 14 and times 2.31 divided by 3960 divided by 0.7 divided by 0.9 is equal to 85.25 horsepower. So, the next standard size horsepower rating is 100. So, fire pump would be 100 horsepower, 500 GPM, 185 PSI, total dynamic head, 220 volts or 380 or 460, 3-phase, 6 thirds. Yun. So, yun yung shortcut ng pag-specify ng mga fire pump habang walang pang design si mechanical designer, si fire protection designer. Of course, kung dumating na, i-double check mo na. Maliit ba yung na-assume mo? O tama lang? O sobra ba? Okay. Alam nyo, it's better to have a sobrang konti kesa yung kulang. Di ba? Okay, so now we proceed to air pressurization. This is the stairwell pressurization ng mga hagdanan, no? Pressurization ng mga hagdanan kasi doon tatakbo ang mga tao para lumabas sa nasusunog na building. Okay? So, this is the schematic example where you have a stairwell pressurization fan dito sa ibabaw at yung nasusunog tong third floor, tumatakbo yung mga tao palabas dito sa hagdan hanggang makalabas sa gusali, no? Kailangan itong stairwell na ito pressurized. Ha? Ang magpapatakbo nitong si stairwell pressurization fan ay yung FDAS. Pag naka-detect yung FDAS mo ng smoke, kunyari, andito yung smoke detector mo at nakatanggap na siya ng smoke, di ba? Pagaganahin na niya yung FDAS, Fire Detection and Alarm System, Fire Alarm Controller, at si FACP, magbibigay ng signal sa starter ni itong air pressurization fan para umandar automatically at mag-i-inject siya ng fresh air dito. Kukuha lang siya sa labas ng building, sa ibabaw, at ipapasok niya rito. In other words, ipipressurize niya konti itong load nito. Bakit? Kasi ayaw natin na itong usok lalabas sa fire exit door at pahihirapan niya yung mga tumatakas na tao sa hagdanan hanggang sa maka-exit dito. Hirap kaya yung mausok yung kinalalagyan mo, no? Okay, so yun yung dahilan na meron tayong air stairwell pressurization.
1.2.3 Stairwell Pressurization Fans, or SPFS, and FPA-92. In the event of a fire emergency, the stairwells are frequently the primary escape route and may also serve as the primary access route for firefighting teams. In these smoke control zones, stairwell pressurization fans, SPF, are used to pressure stairwells to limit smoke infiltration by maintaining positive pressure across closed stairwell doors. Fans used for stairwell pressurization should be designed to operate at low enough pressure so that the exit doors can be immediately opened during evacuation. Just like the fire pump, the SPF system should automatically be operated by means of the FDAS system. It is recommended to use variable frequency-driven SPFS to maintain the correct positive pressure, a pressure differential of not more than 0.25 inch Wg or 62.2 pascals, to prevent the occurrence of an overpressure that may hinder the easy opening of the exit doors.
So yan yung discussion ko dyan sa stairwell pressurization. Sa ngayon, ang ginagamit na is yung variable frequency drive. Kasi nung araw, wala pa itong variable frequency or meron to pero napakamahal. Ang ginagamit is Y delta starter, no? Y delta starter o di kaya naman pwede ring across the line starter or full voltage starting controller or motor, no? Yun yung dati. Ang problema sa ganon, mahirap mo i-calibrate yung andar niya. Pag sumubra ang andar niya, balikan natin. Pag sumubra ang andar nitong motor na ito at sumubra ang pressure, hindi maitulak ng mga mag-exit na tao yung pintuan. Mahirapan sila. Lalo na kung medyo may kahinaan yung tao. Buti kung lahat malalakas, di ba? Walang sakit o ano. Pero kung merong yung tao medyo hirap sa paghinga, ganyan, may kapansanan sa katawan, mahirapan siya dyan. Kung sobrang taas ang andar ng iyong kwan, no? Kunyari, gumamit siya ng across the line, full voltage starting. Mahirap kontrolin yon. Ngayon, with the advent of the variable frequency drive, mas madali nang kontrolin. Kasi maglalagay ka rito ng pressure sensor. Pagka mataas na yung masyadong pressure, pahihinain niya ang takbo ni variable frequency drive ni air pressurization fan. Okay? Nung araw kasi, naglalagay ng relief lower. Ito, no? Yung relief lower, gravity lower, no? Pag malakas yung pressure, bubukang ganyan para lumabas yung hangin. Pero mahirap i-calibrate yun. Hindi katulad kung may pressure ka dito, pressure sensor, siya ang pwedeng mag-send ng signal sa fire alarm control panel at para pabagalin o pabilisin itong controller nitong pressurization fan. Okay, so yan. So ngayon, bigyan ko kayo ng parang rule of thumb, ano? Okay, so rule of thumb, use 200 cubic feet per minute per floor. So habang mas mataas yung gusali mo, say ito, sample, 12-story building. So 12-story, ang specify mong motor or fan, yung CFM capacity, cubic feet per minute, will be 200 times 12 or 24,000 CFM. Kung mas mataas, ito naman, no, 22-story, 44,000 CFM. Kung ito naman, 37-story, pwedeng 74,000 CFM. So, ibig sabihin, pwedeng gumamit ka ng dalawang fan o tatlong fan. Tignan mo lang kung paano mo i-portion. Pwedeng, kung 37, divide mo siya sa divide by 3. So, that means every 9 stories, no? Every 9 stories, meron ka dapat injection ng fresh air. Okay? Now we go to Tugadex. Itong Tugadex, pinorm ko itong word nito para magtanim sa kaisipan ng marami. Kasi ito yung bago. Hindi pa malaganap ang paggamit nito. Tayo pa lang ang nagpupush nito, no? Kasi medyo nung nangyari yung Resorts World Fire, sinimulan natin na i-suggest na dapat magkaroon na ito, no? Kasi yung ating FDAS, Fire Detection and Alarm System, ang meron lang doon smoke detection tsaka heat detection. Wala siyang toxic gas detection. Okay? Ano yung toxic gas? Itong carbon monoxide is a toxic gas. Kung magkaroon ng incomplete combustion sa loob ng isang enclosed na gusali o air conditioned na gusali, malamang meron kang carbon monoxide na ito ay nakakamatay. Okay? Then, pwede rin makaproduce ka ng hydrogen sulfide. Hydrogen sulfide is also a highly toxic gas, no? Flammable na toxic gas pa. Pati si carbon monoxide, toxic gas na siya pero flammable din siya. Ito namang si methane. Itong methane kasi pwedeng manggaling yan sa septic tanks, sa sewer, sa sewage. Okay? So si methane naman at saka si LPG, hindi man sila toxic pero highly flammable. So delikado rin kasi kung di mo ma-detect na meron kang methane doon at nagkaroon ng spark, pwede mangyari yung malaking pagsabog katulad nangyari doon sa Glorieta noong 2007. Kung maalala nyo yung Glorieta 2, sumabog noong 2007. At ang kadahilanan is there was methane gas na naipon doon sa basement. Kasi hindi na-maintain yung mga sump pump, yung magta-transfer ng maduming tubig palabas sa building, no? Nandun, naipunan sila. At nung maipunan sila, yun, nag-aantay na lang ng pagsabog at sumabog, 11 tao ang namatay doon. So, dapat hindi na natin payagan na mangyaring gano'n, no? Dapat maglagay na tayo nitong toxic gas detection and extraction, no? Toxic, TO, gas, DE, detection and extraction. Extraction meaning to say, higupin mo palabas sa building. At ito yung aking schematic. Pinakita ko na to dun sa bakong mga lecture, yung fire and life safety. Pero syempre, hindi naman lahat nakapanood doon, so hindi na-mention natin dito, no? So, ang tawag ko sa kanya ngayon, TUGADEX. Toxic Gas Detection and Extraction. Okay. So, ito yung mga explanation. Pinaliwanag ko na rin sa mga previous kong lecture nito, pero dapat yung mga ngayon lang nakakita nito, dapat pag-aralan nyo rin kasi ito yung delikado na pwedeng papatay ng mga tao in case na magkaroon ng sunog sa isang gusali, no? So, kailangan, ang solusyon dyan, you have to be able to detect carbon monoxide, no? So, you must have detectors. At magpapatunog ka ng alarma, yan, alarm. At magpapagana ka ng ventilation or exhaust fan para higupin mo palabas yung toxic gas. Ito, colorless, odorless, tasteless, toxic or poisonous gas. Yan. Hydrogen sulfide, sinabi ko na, napakadelikado nito. Again, you should have a gas detector, hydrogen sulfide gas detector. Tapos magpapatunog ka ng alarma at kailangan higupin mo na palabas sa gusali yung H2S na yan, o hydrogen sulfide. H2S is colorless, corrosive, flammable, toxic, poisonous gas. No? Itong si H2S, ang kagandahan nito, pag naamoy mo siya, mabaho siya. So, yun, magbibigay ng warning. Ang problema lang, kung minsan tayo, nasisira pangamoy natin, lalo na kung meron tayong matinding sipon, di ba? Kaya hindi assurance na maamoy mo siya. So, pinakamaganda, meron ka dapat detector. Okay, so hydrogen sulfide, LPG is also very dangerous. Dapat meron kang LPG gas detector at automatic pasasarhan mo yung solenoid valve para hindi na magtuloy pa ang supply ng gas. And then methane, yan sinasabi ko na methane is also a product of the sewage system from the septic tank. When you produce methane, then there is a big danger, no? So methane detectors are needed, should also sound an alarm and automatically run extraction fan if they are inside the building. Otherwise, kung hindi mo i-extract at na-ignite, ay malaking sabog. And here is a way to install a detector, a gas detector, to your exhaust fan in your bathroom. No, if you happen to have a bathroom exhaust fan and you are living in a condominium unit, you can follow this simple diagram to install your extract. The plumbing engineering course is quite lengthy, no? So you also need to prepare a thesis, plumbing engineering thesis, which should include all the aspects of plumbing as well as hydraulic calculations for sprinkler system. So medyo mahaba siya. Okay? But if you just want to get a certificate sa how to prepare plumbing plans or how to do the plumbing inspection, or then you just watch the video as we are usually doing, no? You can go back to those uploaded videos already. You finish it from start to the end and then ask questions, and then you can ask for a certificate of attendance, virtual attendance. Okay,